Hello and welcome to Train Signal. You're watching Storage I/O Control, or SIOC. In this lesson, I'll be talking about why you need Storage I/O Control to begin with. I'll cover how Storage I/O Control works and what the requirements are to use it before I show you how to enable Storage I/O Control in your vSphere 5 virtual infrastructure. And then we'll end the lesson with how to monitor Storage I/O Control performance. So with that, let's get started. Storage I/O Control is a relatively new feature in vSphere, starting with vSphere 4.1, and it's got an additional feature now in vSphere 5. So why do you need Storage I/O Control to begin with? Well, the general consensus is that most virtualization performance issues are caused by latency in shared storage. So in other words, to use vSphere, 99% of the people out there are going to have some shared storage, and you'll need that shared storage, of course, to take advantage of features like vMotion, DRS, and VMHA. So you've got that shared storage, you put all your virtual machines on it, but then that shared storage can become a point of contention for the ESXi servers and the virtual machines. So what Storage I/O Control does is it provides that quality of service to ensure that virtual machines get the storage performance that they require. So as long as you have plenty of bandwidth and plenty of resources, of course, contention is never a problem. But when you get so many requests on a specific resource, in this case storage, performance can become an issue, and then you'll start to see latency and slowness in the virtual machines and the applications. So then quality of service is needed to step in and to ensure that the virtual machines that are the highest priority in the infrastructure get the resources that they need. So in summary, SIOC is necessary so that one virtual machine doesn't slow down another regarding storage resources. Or to be more realistic, it's usually a handful of lower priority virtual machines slowing down a handful of much higher priority virtual machines. So you could have, let's say, virtual desktops with end users out there that are watching videos or something, or even, let's say, print servers or file servers or web servers that perhaps aren't as high a priority as other virtual machines in the infrastructure that need access to the same storage. So Storage I/O Control is here to step in and ensure that the highest priority virtual machines get the performance that they need. So how does Storage I/O Control work? Well, if you look at the left-hand side diagram here, or graphic, you've got two ESX servers, and they're accessing the same shared storage array. This diagram from VMware.com shows those two servers have shares configured. So Storage I/O Control right there, there's a hint, it uses shares. Just like you would have shares configured in a resource pool for CPU and memory, Storage I/O Control uses those same shares. So you've got the shares already configured in your resource pool or on individual virtual machines. Why not use those shares for storage as well? So you've got the two ESX servers, and they've both got shares configured, but they're not getting the proportionate amount of the shared storage access or the resources from the shared storage. So it isn't space, although when you look at the diagram there, you might think at first glance that it's controlling how much space those virtual machines get. It's actually the performance that the virtual machines get out of the storage array. So it's the storage array queue and their priority in that queue. So on the right-hand side, with Storage I/O Control enabled, you can see the resources and the proportions of those resources in the storage array queue. Those have changed drastically because virtual machine A has 1,500 shares allocated to it, whereas virtual machine B and C only have 500 each. So virtual machine A should be getting 60% of the storage array queue, and virtual machine B and C should only get 20% respectively. Whereas before, virtual machine A was only getting 38% of the storage array queue, and virtual machine C was actually getting 50%, even though it only had 500 shares allocated compared to 1,500 shares for virtual machine A. So this is an example of before and after enabling Storage I/O Control. And it shows you how with the ESX servers communicating to one another, the shares that are allocated to the virtual machines, those virtual machines can get the priority that they deserve in the shared storage array queue. So what are the requirements to use Storage I/O Control? Well, first off, the data stores must be managed by a single vCenter server. So the data stores between these ESXi servers must be managed by the same virtual center server for you to be able to use storage I/O control, and that's because these shares are going to be stored in the vCenter server. It's the vCenter server that's communicating the number of shares and then specifying the amount of the storage array that those virtual machines across multiple ESXi servers, all accessing the same data store, the shares that those virtual machines deserve. You can use either Fiber Channel, iSCSI, or NFS, which is brand new in vSphere 5. With vSphere 5, you can now use NFS with storage I/O control. RDMs are not supported, but Fiber Channel, iSCSI, and NFS are. Data stores with multiple extents are not supported, and you have to have vSphere 4.1 or later really to use storage I/O control, and if you want to use NFS, you have to have vSphere 5 or later. Now that we know what SIOC is and how it can help us, as well as the requirements to use it, it's time to get started by enabling SIOC, and this is done on each data store in the virtual infrastructure. Once it's enabled, the ESXi servers will monitor the latency of that data store, and once the latency reaches a certain threshold, those servers can begin to throttle the storage I/O requests based on the share values that are given to each of the virtual machines making those storage I/O requests. To enable SIOC, which I'll show you here in just a second, you would go to the ESXi Servers Configuration tab, into Storage, select the data store, click on Properties, and you'll find a checkbox there where you can check to enable SIOC. It's super simple. Now, once it's enabled, you'll want to go and set the number of shares and the maximum number of IOPS per virtual machine. Of course, this is really optional. If you just want all the virtual machines to have the same amount of priority in the storage I/O queue, then you really don't have to configure the shares on every virtual machine. But if there's certain virtual machines that you want to have higher priority and certain virtual machines you want to have lower priority, or if you want to configure a maximum number of IOPS on particular virtual machines, then you can do that. And I'll show you how in just a second. Now, there's a big note here from the documentation, the VMware official documentation, and it says, if the limit you want to set for a virtual machine is in terms of megabytes per second instead of IOPS, you can convert megabytes per second into IOPS based on the typical I/O size for that virtual machine. For example, to restrict a backup application with 640 kilobytes of IOPS to 10 megabytes per second, then you can set a limit of 160 IOPS per second, or IOs per second. So there is a conversion that you need to know about in case you want to restrict the maximum number of megabytes per second for a particular virtual machine, but the vSphere client is only going to allow you to specify the number of IOPS per second. So you can actually do this conversion to convert megabytes per second to IOPS per second if you need to. Now, to set the SIOC shares and maximums, you can go to the Data Stores view in the vSphere inventory and then select the Virtual Machines tab. Or you can go to the Properties of each virtual machine and then to the Resources tab. You can monitor SIOC latency and IOPS in the Data Store Inventory Performance tab. So now let's go over to our vSphere client and I'll show you how to enable storage I/O control, how to configure the shares and maximum number of IOPS if you want to do that, and then how to monitor the SIOC latency and IOPS in the data store inventory. Here we are in the vSphere client, and I've selected a particular ESXi server over here on the left-hand side in the Hosts and Clusters inventory. Currently, I'm on the Summary tab, but to configure storage I/O control on a data store, you would go to the Configuration tab and then down to Storage. Inside Storage here, you would select the data store where you want to configure SIOC. And then on the right-hand side here, I can select the Properties. And then right here, this is the checkbox that's most important. You check that checkbox, and you see that storage I/O control is now enabled. If you want, you can go into the Advanced option here, and this is where you configure the congestion threshold value. And it gives you a big warning here that if you modify this, it could be detrimental to the performance of the entire data store. I'll say OK, and actually I'm not going to change it. The default is 30 milliseconds, where storage I/O control actually kicks in. When there's 30 milliseconds of congestion or greater, storage I/O control kicks in, and the storage I/Os going to this data store start to be throttled based on the amount of shares and the maximum number of IOPS that you specified per virtual machine. So I'm just going to click Cancel here. Notice storage I/O control is enabled. I'll click Close. And at this point, it's actually enabled. We're all done configuring storage I/O control. All we had to do is go in and check that one checkbox. However, it's only done for this particular data store. So if you have multiple data stores, you need to do it per data store. So I'll click on another data store here, and I'll click on the properties for this, and I'll go ahead and enable storage I/O control on this data store. So I've got two data stores here going to the same iOmega SAN connected to this particular ESXi server. So if I go to this other ESXi server here on our cluster, and I go into storage here and select one of the data stores, then click on properties, notice that storage I/O control is already enabled here. So I don't have to go to every ESXi server to do it. I only have to do it per data store on one particular ESXi server. And it has to also span the same vCenter server. Keep that in mind. If you had multiple vCenter servers, you would have to do it per data store, per vCenter server. So I'll close this out, and at this point, storage I/O control is enabled. Now, what about configuring the share value and maximum number of IOPS on each virtual machine? There's a couple different ways you can do that. First off, you can just right-click on any virtual machine, go into Edit Settings, then go up to the Resources tab and click on Disk. It's here that you can configure the shares for this particular virtual machine from low to normal to high, or even a custom value. Additionally, you can configure the maximum number of IOPS that this virtual machine is going to receive from the data store that it's currently located on. Now, instead of doing it per virtual machine, you can actually go and do it on a very nice column view. If you go into the data store inventory, right here, I'll go into data stores and data store clusters. Then I'll select a particular data store that we have storage I/O configured on. Then go to the virtual machines tab. Here in the virtual machines tab, if we scroll over to the right-hand side, here you can see the share values for these virtual machines. And the most useful thing that I just found out by going to this view that I couldn't see by going to every virtual machine individually is very quickly I can scan for the share values that are configured across all virtual machines on this data store. And notice right there that this last virtual machine has 3000 or high configured for the share value. I can sort right here by the share value with the highest share value on top. Then I could just right-click on the virtual machine and again go into the Resources tab and make a change to the resources for that virtual machine. And what do we find by doing that? Well, actually, this virtual machine doesn't have just one virtual disk. It has 3 virtual disks. So because it has 3 virtual disks, that's how it came up with a share value of 3000. That's because it has 3 virtual disks. Each virtual disk by default gets a normal share value, which is 1000. So you add that up, and there you go. There's 3000. When I first saw that 3000 over there, I thought, oh, someone must have gone in and misconfigured the share value for that particular virtual machine when I wasn't looking. But the more I dug into it, the more I went to the Resources tab here, and then I was able to see, hey, wait, there's actually 3 virtual hard drives for that particular virtual machine. So it adds those up, and that's how it gets the 3000. If we go back here, you can also notice the percentage of data store shares. So that virtual machine has 60% of the data store shares. And if we notice on the left-hand side here, notice that that virtual machine is on a different host. So back to the diagram that we were looking at in our slides, where before storage I/O was configured, the virtual machines had a really messed up percentage of the data store disk I/O queue. Whereas now with storage I/O control enabled, we can see their data store shares have been adjusted accurately based on the share value that particular virtual machine is allocated either by default or which you configured based on the priority of the applications on that virtual machine for your business. Now, hopefully with storage I/O configured on that particular data store, you won't have to worry about latency affecting the applications on these virtual machines. However, it could get to the point where, let's say a high priority virtual machine is really hitting that data store hard, and there's other virtual machines that have lower shares, and they're actually being negatively affected. So just because you have storage I/O configured doesn't mean that you'll never run out of storage I/O or IOPS on a particular data store. But thankfully in vSphere 5, we have storage DRS, or the Storage Distributed Resource Scheduler, that's going to use storage vMotion to move virtual hard drives from one data store to another for a running virtual machine when that data store starts to see poor performance or high latency. Now, we've got a whole separate lesson that covers storage DRS, so I'm not going to cover it in this lesson. But how you go and look at the latency on a particular data store is to go here into the Performance tab underneath the data store inventory. And the default is to view by space here, but we can change that to view by performance. And then we can see here the latency for that data store in microseconds. This is actually in microseconds. And if we scroll down, here's the data store latency in milliseconds. So we saw that the latency threshold for storage I/O control was 30 milliseconds, not microseconds, milliseconds. And right now, this data store through ESX1 is pushing about 4. It's hitting up to 4 milliseconds. So we're nowhere near that threshold, and storage I/O control hasn't kicked in, but then we only have a handful of virtual machines on this particular data store. In fact, to be specific, we have 3 virtual machines on this data store. So there's not a lot of activity. You can also go down here and you can look at the read and write IOPS per host, as well as the average read and write latency per virtual machine. So there's a lot of very useful statistics in the Performance tab here for this data store. You can, of course, go back in time to 1 week, 1 month, 1 year, or a custom view, or you can even view real-time data store latency, IOPS, queue depth, and read and write information for a particular data store. So that's how you monitor the performance of a data store once storage I/O control is enabled. Of course, you would want to monitor the performance before it was enabled as well, but once it's enabled, this is where storage I/O control is looking to find out the latency for a particular data store. And if you're not using storage DRS, if latency does increase, even with storage I/O control, you could have poor performance for the virtual machines that have a lower number of shares, and you might want to move those virtual machines off onto another data store, or move the highest hitting, hardest hitting, highest demand virtual machines off to another data store. Some way manually balance the load if you're not using storage DRS. But of course, I highly recommend storage DRS because it's new in vSphere 5. All right, so that's storage I/O control, and with that, we can go back to our slides. And that brings us to the summary for this lesson. We started off by talking about why you need storage I/O control in the first place. It's so that a handful of high priority, high demand virtual machines don't negatively affect the performance of other virtual machines that are all sharing the same data store. With storage I/O control enabled, you can use the share values in vCenter and set priorities for those virtual machines to ensure that the highest priority virtual machines get the access or the storage I/O to the data store that they require. And by the way, storage I/O control only kicks in when that data store hits a high watermark or a congestion threshold. There are some requirements for storage I/O control. You need at least vSphere 4.1, and you need vSphere 5 if you're going to use storage I/O control on an NFS data store. All the ESXi servers with virtual machines on that data store need to be talking to the same virtual center server, and enabling storage I/O control is super easy. As you saw, you just go to each data store and you check the checkbox that says Enable Storage I/O Control, and you only have to do it once per data store, regardless of how many ESXi servers are actually using that data store. Monitoring storage I/O control performance is, again, very simple. You go into the data store's inventory and then to the Performance tab where you can see latency, IOP, and queue depth statistics for that data store. Thanks for watching this lesson on a very cool feature of vSphere 5, storage I/O control, or SIOC.